Hello guys, in this video we're going to talk about the worksheet 9.3A level 2 plus. So it's about the joints variation again. So the first question is saying that we have the z is various jointly as x squared and y to the power of 5, which means we can write that as the z is directly proportional to x squared y to the power of 5 because they're jointly proportional, which means that these two can times together. And after that, we can change our efficient sign into equal to k. So we can change to z is equal to k x squared y cubed. So the condition we have is x is equal to -2. So we have x is equal to -2, y equal to 3, z is equal to 3,888. So then we can substitute these three values into our equation here. So we got the z, we got the x, we got the y, then we can find out the value of k. Then we can say we have the 3,888 is equal to k times -2 squared times 3 to the power of 5. Then we have this -2 squared. So be careful, -2 squared is not equal to, -2 squared is not equal to -2 squared. So this means that we calculate the squared first, then we're taking the negative. But for this one, this means -2 times -2, which will give you a +4. So just be careful about this part. So for the -2 bracket square, we can have this is equal to 4. So 4 times 3 to the power of 5, which will give you an answer of 972. So we have 3,888 is equal to 372k. Then if you're using your calculator, then it's equal to 3,888 divided by 972. So the k is actually equal to 4. So every time we got the value of this k, then we substitute back to our original equation. Then we can have z is equal to 4x squared y to the power of 5. So this is the equation connecting x, y, and z. So this is for our part A. Then we have our part B. The answer is, the question is saying that find the values of x if that y equal to -4 and z is equal to a large number, which means that we just substitute the y to be here, the z to be here. So y, they give you a bracket values, so which means that x may have more than one values. So just be careful about this. So now we can substitute z is equal to the -36,864, which is equal to 4x squared. We want to find out the x, so we keep the x, and the y is equal to -4, all the thing to the power of 5. So in this question, then we can say that the -36864, which is equal to 4x squared times, so -4, all the thing to the power of 5. So which means that it's -1 to the power of 5 times 4 to the power of 5. So if you have an odd power, which means that finally will give you a negative number, so we just need to calculate 4 to the power of 5. So 4 to the power of 5 times the original 4, which will give you 4,000 something, I think. So 4 to the power of 5 will give you like -1024. So if you calculate these two times together, then we can have -36864 is equal to -4096 x squared. So just using a calculator, then you can get our x squared is actually equal to 9. So every time you get something squared is equal to something, don't just give me the square root as the answer. So please write it as x is equal to plus or minus square root of 9, which means that it's equal to 3 or -3. So basically how it works is actually using one of the identity you learned in Form 2. If we move the 9 to the left hand side, we got x squared minus 9 equal to 0. Then we can, using our formula, a squared minus b squared is actually equal to a plus b times a minus b. So in this formula, we can have x plus 3 as 3 squared is equal to 9. X plus 3 times x minus 3 is equal to 0. So then we have the x's can either be 3 or -3. So this is for question 1. Alright, so now we're moving to question 2. Question 2 is saying that the L is varies directly as square root of n and inversely as n cubed. So as what I said before, the inversely can change to directly. Then you need to change n cubed to become 1 over n cubed, which means that we can write something like the L is proportional to the square root of n times 1 over n cubed. Then we can change our proportional sign to become equal to k. Then we have the L is equal to k square root m divided by n cubed. As the condition saying that m is equal to 64 and have the negative 2, L taking the half, then we can just substitute all these three values back to our equation. Then we can have the L value, the n value, the n value, so that we can find out what is the value of k. So which means that after substituting it, the L is equal to a half, which is equal to keep the k, square root the 64, which is the n values 64, so we divided by negative 2 cubed. So a lot of students write square root of 64 equal to 8 squared, which is completely wrong, because square root 64 is just equal to 8, so we just want to take the square root. So what we need to do is to find a number square will give you back the 64, so obviously the number will be 8. So square root 64 is just equal to 8, so the numerator we have is 8k, and then divided by negative 2, the whole thing to the power of 3, which means that it's negative 2 times negative 2 times negative 2. So 3 negative times together will giving you a negative as well, so 2 to the power of 3 give you 8. So on the denominator we got negative 8, so we can eliminate the 8, then we can have the negative k is equal to a half. But be careful, we need to move the negative sign here as well. Then we have the k is actually equal to a negative half. After we get the value of k, we put it back on our original formula. Then we can have the L is equal to a negative half square root m divided by n cubed. If you rearrange it, then we can have a nicer look. Then we have this negative square root n divided by 2n cubed. So that's the relationship between L, m, and n. So the question B is asking is that square root m over ln cubed is a constant. This looks like very weird, but however, if we look back to this equation, so as we have that the L is equal to k square root m divided by m cubed, where k is a non-zero constant. So which means that we can rearrange it. Then we can say we change the n cubed to be here, we change the square root m to be the denominator, then we can say this is equal to ln cubed divided by square root m is equal to k. So as k is a constant, right? It's a non-zero constant. If we rearrange, if we swap the numerator and denominator, then we can have the 1 over k is actually equal to the square root m divided by ln cubed. So that's how this square root m over ln cubed comes from. It's just like our 1 over k. So which means that 1 over k is also a constant. So which means that this one is also a constant. So B is correct. Okay, so now moving to question 3. So some of the students may think this is quite hard because it's all wording, a lot of word. But take it easy. As I said before, just take some main word to highlight. So for example, we are talking about the simple interest. So simple interest, we can just take it as I. It varies jointly as the principal. So varies jointly, so both of them are directly proportional to I. So we have I is directly proportional to both of the principal and the time deposit. So we can just write this is proportional to P and proportional to T. So that we can write it as the I is proportional to PT, which means that the I is equal to KPT. So that's the first equation that we have. So the condition that we have is a person deposit $2,000 for 4 years and will earn the interest of $320. So deposit 2,000 means that our principal is equal to 2,000. Principal means the money that you put into the bank at the first time. So the principal is equal to 2,000, and our time deposit, the t, is actually equal to 4, and the interest I is actually equal to 320. So we just substitute the values back to our equation, then we can have 320 is equal to the k times the p, which is 2000, times the t, which is the 4. Then we can have k is actually equal to 320 divided by 8000. So overall it will equal to 0.04. So after that, they're asking you to find out the sum of money deposited by Peter if he will receive an interest of 1,400 after 7 years. So now we have, oh sorry, I made a mistake as well. I just find out the variation constant, I forgot to put it back. So which means that the I is basically equal to 0.04 pt. So that's our final answer, which is link the interest, which link the principal together with the time deposit. Then now the constant, the condition says that interest is equal to 1,400 after 7 years. So which means that we have our I is equal to 1,400, the time deposit is equal to 7, and what is the value of P? We just substitute these two values back to this equation, then we can find out the value of P. So the I is equal to 1,400 is equal to 0.04. The principal is something that we want to find. T is equal to 7. So after using the calculator, we can find out the P is equal to 1,400 divided by 0.04 times the 7. Then by using your calculator, you can find out the answer will equal to 5,000. So if you at first deposit for 5,000 for 7 years, then you after 7 years you can get this $1,400. So but actually, what is the meaning of this 0.04? It's not something in mathematics, it's actually in accounting or in BFS. But actually this 0.04 is equal to 4%. So this 4% is actually representing this fixed interest rate. Okay, so that's just some additional information for you guys. You don't really remember that. You only need to know how to do the math in my subject, and that's fine. Okay, so now moving to the DSC types questions. It's not that hard, but we can just try to do them step by step. So at first, the z is various as x cubed and y to the power 4, which means that z is proportional to x cubed and y to the power 4. After using this fish, we can change it to equal to k. Then we have equal to k x cubed y to the power 4. And the condition we have is x, y, z. So we can put it back into our formula here to get the 45 is equal to k times 3 cubed times 1 to the power of 4. So 1 to the power of 4 just give you 1, and anything times 1 will give back the anything. It's just ignore this 1 to the power of 4. Then we can have this 45 is actually equal to k times 27. Then we have the k is equal to 47 divided by 27. And the common factor is 9. Then we have 45 divided by 9 to get a 5. 27 divided by 9 get a 7. So the variation constant is 5/7. Then now we need to put back this variation constant back to our original formula, so that we have the z is equal to k, which is 5/3 x cubed y to the power of 4. So that's the formula connecting x, y, and z. So now the question is asking to find out the value of z when x is equal to 1, y equal to -3. So now we have the x is equal to 1 and y is equal to -3. We basically just put these two values to be the x and y values, then we can find out the value of z. So we have the z is equal to 5/3 times 1 to the power of 3, -3 to the power of 4. So 1 to anything power, which will give you back a 1. So this one can be ignored. We just consider about this thing. So do you still remember a negative number to the power of an even number power? That is going to give you a positive number. So the z is actually equal to 5/3 times 3 to the power of 4, which is give you 81 for this. So the final answer will equal to 135. So that's for question 4. So now we're moving to question 5. I think all of the students don't know how to do it. It's a little bit tricky, but however, it's quite obvious for you to think about. So If you don't understand something, just try to erase it. So for example, when the value of q is fixed, what's that mean? So just erase it. So now we have the z is varies inversely of PR squared, and the z varies as square root q. So when it says it's inversely, we can change it to directly, and we change the PR squared to become 1 over PR squared. So z is directly various as 1 over PR squared, and is various as the square root q. So you can just combine them to become the z. Sorry, I used blue. So basically just means that z is proportional to the 1 over PR squared times the square root q. So then we can write it as that z is equal to k square root q divided by PR squared. So what's the meaning of when the value of q is fixed? So which means that the k and q, they are both constant. So if k and q both are constant, then we have a big K here. So if a big K as a numerator, which means that the z is inversely proportional to PR squared, right? And for the next sentence, if p and r are fixed, which means that the k, PR squared, they are constants. So we keep this one as a big K, then we can have the z is proportional to the square root q. Then we can have the formula that the condition that we have is p, q, r, z. We can just substitute back to our formula here. Then we have the z is equal to -1 is equal to k times the square root q. We got square root 16 is divided by p, which is -3, and r is 1, so we have 1 squared. So now we can simplify to get -1 is equal to k times 4 divided by -3, and 1 to the power of 2 is actually just equal to 1. So we put the things on the left hand side, and we can get the k is actually equal to -1 times -3 divided by 4. Basically means the k is equal to the -1 times -3 gives you a positive. So now we have a positive 3 over 4. So after you got this variation constant, you just put it back to our original formula. Then we have the z is equal to 3 over 4 square root q divided by PR squared. So that's the formula connecting z, q, pr. So this time we got 4 variables, but it's just doing like the same way. So after that, we need to find out the value of p when this 3 values is given to you. Then we just substitute back to our formula. We know that the z is equal to 9 over 32 is equal to 3 over 4 times the square root of q. Q is 81 divided by p is something that we want to find out, and the r is 2 squared. So using a calculator, you can get something like the p is equal to 6. All right, thank you.